Hi, and welcome to another in the ARM What Is Program series. In each episode, we dive into a tech topic to give you insight and perspective into some of the hottest design trends today. I'm Brian Fuller, Editor-in-Chief at ARM, and today we're going to explore TinyML, which, if you're not familiar with it, is not something an entomologist worries about. Machine learning is a subset of artificial intelligence in which devices themselves learn from data to perform tasks better. Today, to help us understand TinyML are two giants in the field, Laudick and Steve Roddy. Dennis is head of AI and machine learning marketing at ARM, and Steve is head of products for AI and ML. And here's something you might not know about these gentlemen. Dennis is an avid rower and runner and has lived for many years in China. Steve currently is hunkered down in a mountain hideaway where he enjoys working with chainsaws and burning debris. Let's dive right in. I'm going to start with Dennis. Give us a better description of machine learning, if you don't mind, and then tell us about TinyML in that context and why we should care.
Yeah, so machine learning is often interchanged with artificial intelligence in nowadays. So artificial intelligence is a machine's ability to learn things. There's many ways to do that, but the one that's causing all of the excitement at the moment is a methodology called machine learning. And machine learning is about creating a model, using lots and lots of data, a model to represent something. So the classic example is a cat. You use thousands of pictures of different things to let a machine figure out what a cat is. Then you use that model to test against a new picture, and it can tell you whether or not it's a cat or not with pretty high level of certainty. So quite exciting stuff, very complex, and we were struggling with this in computer science, and now we can do it. And it applies to a huge range of applications, so which is great. Now, TinyML is something I'm particularly excited about. And this is, a lot of the original machine learning was happening in the cloud and the experimentation was happening there. But over the course of the last 5 years, it started to move more and more into devices. And we started to work out use cases and applications in the small space, in the device spaces around you. And this is starting to go everywhere. But to do things in the modern technology world, you kind of need a community. You need a community of knowledge, capabilities, of input, and that's kind of what TinyML is. TinyML is a community of people interested in bringing this amazing technology down into the devices around us.
Got it. Steve, they say good things come in small packages. How tiny is tiny?
Good question. Pretty much any place you have a microcontroller today, and there are tens of billions of microcontrollers shipped annually, you can run machine learning workloads in the device at the source of the information. As Dennis was saying, when machine learning took off in the last few years, all the excitement, all the experimentation was in the data center because it was all about inventing new algorithms, new models that could recognize things with greater and greater accuracy, exceeding human ability. And then people realized, well, in order to actually run the models, you need to be close to where the data is. So there are, think of like an elevator where, you've got sensors on the motors and the shafts and the chains and the pulleys, and you want to know when the device is getting, dangerously close to failing. You want to be able to do preventative maintenance. You want to listen for vibrations in motors and things. Well, the place to do it is there where the data is, where the device happens to be. And if you have a microcontroller controlling something, and you're sampling data at very low hertz rate, you can run a small machine learning model and listen for variability in the motor and realize, oh, it's about to fail. So I need to shut my production line down. I need to turn my conveyor belt off. I need to stop the escalator in the shopping mall before something bad happens. So pushing this capability to the very source of where the data comes from and being able to recognize sounds or voices or pictures or patterns. The tiny part refers to the small endpoint processing, but it's part of an overall system. So, think managing traffic in a city with lots and lots of intersections and lots of traffic lights, right? You're going to have some global level optimization, but you're going to have some localized optimizations as well.
Dennis, how do you see this technology evolving in the next few years, and what kind of expanded use cases might we see?
Yes, this is quite an interesting one. So, Steve and I, we've been working in this area for a number of years now, and to be honest with you, it's still accelerating. The learning, what we can do with this technology is just continues to go into more and more places. I've heard it referred to as software 2.0. I've heard it referred to as a universal function generator, which, in computer science, a lot of what we're trying to do is create complex algorithms and functions. So having this tool is incredible. We see it going everywhere. Literally every device category ARM is involved in, we see machine learning happening in more unique and unexpected ways. So I'm really amazed now that machine learning is really starting to happen down at the edge and the endpoints. I'm quite excited to see where this is going to go. It's going to really change things.
Well, thanks, guys. I think we know a lot more about TinyML than we did just a few minutes ago. Check out all our other What Is episodes here, and be sure to subscribe to this channel because we'll be adding more episodes as the year progresses. Thanks for listening.